Good morning, student. This is our physical chemistry lecture. The chapter number is 4th crystal structure. So, in our previous lecture, we have discussed about the law of crystallography, that is, law of constancy of interfacial angle, first law of crystallography. Then, second law is law of rationality of indices, that means the different plane have intersect on different three coordinate axes. Third law is law of symmetry. That symmetry element consists of plane of symmetry, axis of symmetry, and center of symmetry. Now we will see the crystal structure, that means in microanalysis. If you see the crystalline compound under microscope, you will find a very fine crystal, that means fundamental unit of the crystal. This fundamental unit of the crystal lattice is called as unit lattice. That means for the association of these fundamental units or unit cell to form a big crystal, that means a fundamental unit of crystalline compound, that means very smallest part of crystal, we can also call as a single crystal, and this single crystal is called as unit cell. So let us see what is unit cell. Unit cell is a smallest repeating structural unit of the crystalline solid, or it is called as fundamental unit of crystalline substance, is called as unit cell. Now if we find to identify this unit cell, that means where is atom is associated, where is interfacial angle, where is the interfacial angle, what is the edge length, that means distance between the two atoms, we can say bond length, that we can determine by doing the microanalysis. So this is about unit cell. Now the lattice parameter, that means to characterize the lattice we have to assume some constants, is called as lattice parameter. For the edge length, the distance between the two faces, that represented as small ABC, that means ABC is the distance between the two planes, or edge length. In chemistry we can say it is the bond length. The angle between the edges or planes are represented by a constant alpha, beta, gamma, that means the angle between the edges or plane, or we can say a bond angle alpha, beta, gamma, and bond length or edge length. These two parameters are called as lattice parameter. Okay. Then third terminology is space lattice. So what is space lattice? The three-dimensional space occupied by the atoms, ions, or molecule in a crystal is called as space lattice. That means the space in between the atoms or particle in the crystal is called as space lattice. And fourth terminology for the crystal is lattice point. Where is lattice point? That means a position occupied by the atoms, ions, molecule in a space lattice are called as lattice point. If you see the figure, this black solid dots is the lattice point. That means the position occupied by the atoms in a crystal. Suppose this is a unit cell, single crystal. So this dark position will be the lattice point. The three-dimensional space in between this lattice point is called as lattice space. and the lattice parameter will be the edge length A, B, C. This edge length is called as bond length, and the edge angle or plane angle alpha, beta and then gamma is called as lattice parameter, and this single unit is called as unit cell. Okay. Types of unit cell. There are two types of unit cell. First type is primitive unit cell. That means the unit cell in which the lattice point, this lattice point, are present only at the corner. That means the lattice point present at the only corner. This type of unit cell is called as primitive unit cell. That means first find out or investigate this type of unit cell. So crystallographer have again to study the different crystalline compound, and they found that the other type of unit cells, that is non-primitive unit cells. The unit cells in which particles, lattice point may be atoms, ions, molecule, are present at the corner of the unit cell as well as some other position of the unit cell. There are three types of non-primitive unit cell. That means non-primitive unit cell having the atoms present at the corner but some additional atom present other than this corner is called as non-primitive unit cell. And this non-primitive unit cell are of three types. So first is body center unit cell. That means atoms are present at the eighth corner and one additional atom present at the center of the body of the crystal or the unit cell is called as body center unit cell. Second is face center unit cell, in which atoms are present at the corner and additional atom present at the center of each face of the unit cell. The unit cell having cube having 6 faces, that is front, back, left, right, top, bottom. There are 6 faces, and at the center of these 6 faces a atom is situated, additional atom is present. That means the additional atom present at the center of each faces. That's why this type of unit cell is called as face center unit cell. In short we call as FCC crystal, and this is BCC crystal. And third type of non-primitive unit cell is end center unit cell. That means the atoms are present at the corner, the additional atom present at center of any two opposite faces. That means top, bottom or left, right, front, back, each opposite one of the opposite faces. That means end center unit cell, and shortly we called as ECC crystal lattice. So this is about unit cell. The crystalline compounds are maximum are of 7 types. So we called as 7 basic crystal system. The crystallographer initially found that only the crystalline compounds are the possibility of the 7 types of geometry. That means cubic type, tetragonal type, orthorhombic type, hexagonal, monoclinic, trigonal and triclinic. So this classification is based on the lattice parameter. If lattice parameter A is equal to B is equal to C, then alpha is equal to beta is equal to gamma is equal to 90 degree, then this type of unit cell or crystal is called as cubic crystalline system. Then tetragonal, if the A is equal to B, B is not equal to C, alpha is equal to beta, beta is equal to gamma is equal to 90 degree. So we get the tetragonal crystal geometry. Similar way, if we find different geometry having different lattice parameter, then they have get the different geometry, and this is 7 basic crystal system. After that, the crystallographer Bravis have tried to find out and classify the crystalline system in 14 Bravis lattice by considering primitive as well as non-primitive unit cell. And this 14 crystalline system is called as 14 Bravis lattice. if you see the cubic crystalline system, simple cube, then body center cube, then face center cube, that is FCC cube. So in cubic system there will be three possibilities: one body center, one face center. In tetragonal there will be two possibilities: one simple tetragonal and one is body center tetragonal. Then orthorhombic is only simple orthorhombic. Trigonal is body center trigonal. Orthorhombic is three types of possibilities, that means simple orthorhombic, body center orthorhombic, and face center orthorhombic, and then end cap orthorhombic. Then trigonal is only simple trigonal. Then hexagonal, only simple hexagonal. Monoclinic, in monoclinic cases, that is simple monoclinic, end cap monoclinic, and in triclinic there will be only simple triclinic primitive unit cell. So these are the 14 type of possibilities of the crystalline system by considering primitive as well as non-primitive unit cell, and this 14 crystalline system is called as 14 Bravais lattice. By considering again the symmetry law, symmetry point, the maximum crystalline system is of, by considering symmetry of the crystal, there will be maximum 230 crystal systems is available till the date. That means maximum possibility of 230 crystal is only observed in the universe. So here we will stop the lecture. In next lecture we will see the coordination number of the unit cell, density of the unit cell, number of atom present in the unit cell. Thank you.